Hi everyone, and welcome to this MeaningCloud webinar. Today we'll be talking about two partially separate worlds, the world of traditional data analytics and predictive modeling, and the world of text analytics that makes possible the analysis of unstructured content. And we'll be seeing how to connect and integrate them and achieve the best of both worlds. So before we get started, my name is Antonio and I work at the marketing department here at MeaningCloud, and I'm glad to be your host during the next 60 minutes. For those of you who don't know MeaningCloud, we are a text analytics vendor and we welcome your participation during this session. So if you have any questions and comments, you have two ways to let us know. At any time during the session, you can use the chat feature of your GoToWebinar panel and send us your comments. We'll do our best to answer those as they arrive. And at the end of the session, when we have a scheduled question and answer time, we'll be answering the most frequent ones. And also during the Q&A time, if you want to use your voice to ask your question, just raise your hand using this small button. And then we'll enable your mic so that you can be heard by all the audience. Finally, we are recording this webinar, and during the coming days we'll be publishing the recording and all additional materials from the sessions, all data sets, model processes, etc., as tutorials on our blog. So stay tuned to our blog and emails. So as I mentioned before, the purpose of this webinar is to learn how to combine text and data in advanced analytical models, and to do so in a practical way using real-world tools and examples so that you can visualize the value of it and immediately apply it to your business. So towards that end, we'll be covering this agenda. First of all, we'll be introducing the integrated analytics platform products, and specifically one of them, RapidMiner. Then we'll talk about text analytics, why it is important, why it's difficult, and presenting our product, MeaningCloud. And then we go to the integration of these two worlds, to the combination of text and data analytics, and we'll be presenting our recently launched MeaningCloud extension for RapidMiner, for integrating text analytics into your analytics workflows. Then we'll be using that in a practical case of analysis of comments from Amazon. And finally, we'll talk about application scenarios where you can create value of this combination, and highlight some feature of this extension that makes it useful and valuable. And finally, what the product roadmap is. And we will end with the conclusions and the question and answer part. So, integrated analytics platforms. Essentially, this kind of solution is a result of the market demand for agile environments that can support the complete life cycle of analytics project. By this I mean, first, to be able to import and ingest data from different sources, from spreadsheet to databases, to documents, to web pages, to big data repositories, etc. Then we need to support the data preparation phase. You know, this phase is very resource intensive and very exigent in an analytics project. And by data preparation, we mean from exploration of our data to blending and combining those data and cleansing them so that they can be used for the next step, that basically consists in the modeling and validation step. Here you apply different algorithms algorithms from statistics or machine learning. And the idea is to rapidly prototype and validate your models. Usually this is an iterative process in which you are refining and improving your models. And finally, when your models are ready, we need to what we call operationalize them, which means to deploy the model and to maintain the models so that they can be used and embedded in different application, system, business processes to inform our decision or improve our processes, for example. The idea of this is to enable this rapid iteration of the models so that we can really accelerate our time to value in these initiatives. The application areas of these platforms are very different. I guess you're aware of many of them, like, for example, segmenting or marketing or market or customer base, or, for example, optimizing processes or predicting behaviors or outcomes of different situations or recommending products, etc. So there's a huge variety of scenarios where you can apply these kind of models. So one of the products that are very well known in this area is RapidMiner. For those of you who are new to RapidMiner, this is a product that during the last years has managed to gain a leadership position in the market. They offer an open source version that is free to use. And essentially, this particular product, RapidMiner Studio, is a visual design environment for building complete predictive analytics workflows. It's an all-in-one tool that features hundreds of predefined data preparation and machine learning algorithms to support your data science projects. So, for example, let me go to the product itself and show you how it looks. So this is the RapidMiner Studio running on my machine. You see here this canvas where you can create your analytics workflows. In this part, you have the repository of all your data sources and all your analytic processes. For example, you have here a couple of them. And very importantly, on this operators tab, you have access to these different blocks in RapidMiner. Each of one performs different analytics tasks. For example, operator for data access, for accessing databases or files or web pages or applications. Operators for blending, basically for combining different data sources and performing ETL tasks. Operator for cleansing, for deduplicating, finding outliers, etc. And one of the most important areas is the modeling part, which includes 129, in this case, different modeling algorithms, going from predictive algorithms like Bayesian and neural nets, regression, etc. Also segmentation algorithms, clustering, k-means, correlations, covariance, etc., etc. Different technologies, different kind of algorithms that you can drag and drop into your workflows. And finally, some operators for scoring and for validating your analytic workflow, meaning calculating the performance and the quality of your predictions. And RapidMiner include different predefined methods for doing that. And obviously for each specific block and operation, you can configure its parameters, okay? So we'll see RapidMiner in detail when we go to our demo, but going back to my presentation, the idea behind RapidMiner is that it gives you the ability to visually execute your entire predictive analytics workflow in a single place with these functions for data preparation, visualization, normalization, standardization, modeling with statistical, machine learning, predictive, segmentation, all these different analytics modeling tools, validation of the models using all those visual evaluation on model performance metrics, cluster performance measures, pre-configured ways to measure the quality of your predictive models and the results of your analytics project, and finally the ability to deploy your analytics into your systems, application, processes via different APIs, or also using monitoring tools to ensure the continued performance of your models. A very interesting thing to mention about all this product in general is that they are mainly focused on structured data, for example, data range in rows and columns, and that they have some limitation when it comes to using unstructured data, like text, for example. Which take us to the second item on our agenda. Why should I need to analyze unstructured data? And well, the fact is that nowadays more and more useful information is hidden in unstructured content, like documents or internal records, but also, for example, in interaction through the contact center with my customers or other stakeholders. And finally, social media are creating an explosion of unstructured text. Some analysts say that only 20% of useful data is structured, stored in databases, for example, which leaves the remaining 80% of information in unstructured format. And also unstructured is growing more rapidly, meaning it's more important each day. The problem with unstructured content is that it's not easily processed by automatic means. Computers have a certain degree of difficulties in understanding unstructured content, text in particular. And so this is where text analytics comes in. Essentially, text analytics are tools that help us understand the meaning, and if you want, to extract the semantic footprint of any unstructured document. Okay, they use different technologies like natural language processing or machine learning to process unstructured text and extract different elements of meaning from it. Like, for example, as you can see here, mentions of people, mentions of organization, brands, abstract concepts like that appear in your text. Also, for example, to understand the theme that a document relates to, and also opinions or polarity of facts in general, and lately also a relationship between these other elements that we found on the text, for example, between the different entities that you can identify in your text. So essentially, this is the market we are in as a company. MeaningCloud is the name of our product that we like to call Meaning as a Service. And essentially, it's a solution built around a set of text analytics API. And the vision of our product is make text analytics convenient and accessible to everyone, from big corporation to small entrepreneurs. So you can go to MeaningCloud.com and register for free, create a free account that gives you access to a certain number of requests per month. And if you go to MeaningCloud and register, you essentially have access to these different APIs for different text analytics tasks. For example, you have topic extraction that essentially identifies occurrences of people, organization, concepts, quantities, etc. You have text classification that makes theme categorization of text according to predefined taxonomies. You have sentiment analysis that identifies the general polarity of the document and also an attribute level polarity of the different entities and concepts that are found on the text. For example, you have APIs also for language identification, for lemmatization and post-over-speech tagging that makes detailed morphosyntactic analysis of your text, and different APIs that cover a broad range of text analytics needs. Let me go to the product and show you a couple of things. So this is MeaningCloud. You have an online demo, okay, where you can paste the text, analyze it, and also you have here access to the APIs that I mentioned before, okay, and all of the APIs is very well documented and has a test console that enables you to change the parameters in a certain API and test that API without the need to code anything. So for example, this topic extraction API that, as I mentioned, extracts entities and concepts and quantities, etc. Let me give you an example of how it works. I'm going to use text in English, for example. This short sentence. You see, you can here change the different parameters with the elements that you want to extract, entities, concepts, and several other things. Very importantly, here you can use your own user dictionaries. I will talk about that in a minute. If I send the sentence to the API, it returns this result in which, for example, it has identified a list of entities, including Barack Obama, with official form Barack Hussein Obama II. It's a full name of a person with some semantic information related to it, like, for example, it's related to America, to the United States. Also, the API returns some information from open sources about these specific entities, like, for example, Wikipedia articles and other data, and some semantic information related about this entity that has to do with politics. And also the variant that appear in the test is Obama, okay? Also, another entity that has detected, United States, official form United States of America. It's a country in America. Again, different information retrieved from open sources like Wikipedia and others. The variant of the entity that appeared was USA, and also it has found a concept, an abstract concept like president, which is a title and has to do with politics. You see how rich is the information that the API presents. And finally, it identified the grammatical relationships between the words. In this case, this sentence, the subject is Obama, with the lemma Obama. The verb is was from lemma be, and the complement list is President of the USA. So you see how rich information the API returns from this particular sentence. So I'd like to highlight a couple of features of the product. First of all, is integrability. We are putting a lot of effort in MeaningCloud integrability. For example, all the APIs have developer tools that make it easy to use the API from the most popular programming languages. Also, we provide plugins for different system and applications like Gate environment or, for example, RapidMiner, as we'll see in a minute. And one of the most interesting plugins is the add-in for Microsoft Excel. We're trying to make accessible MeaningCloud to data analysts and non-technical users. The idea is you paste your text into Excel, you click a button into Excel, and the add-in sends the text to the APIs, and the result is presented in a very convenient way within Excel. So everything integrated into your Excel experience, no need to program anything to use the APIs, and basically this is the most convenient way to evaluate, to prototype, and to use MeaningCloud. Another very interesting feature of our product is the capability to customize it. It is very important. We'll see that more in depth later during the session, but it's very important to adapt the working of the APIs to your domain, to your specific application, and meaning you need to extend your ontology or create your personal classification models, or even to create your own sentiment dictionaries. And MeaningCloud includes very powerful and graphical ways to do so. So this was our presentation of MeaningCloud for those of you who were not familiar with the product. And now we're transitioning to the main part of our session today, is how you can integrate text and data into your predictive analytics. And the way to do so is using our recently launched MeaningCloud extension for RapidMiner. So essentially, it's a kind of plugin for RapidMiner that gives you access to different MeaningCloud capabilities that you can download for free from RapidMiner marketplace, and also from our website. You just need to follow that link. And essentially, as I mentioned, it enables you to combine text analytics and your structured data within RapidMiner. Essentially, it gives you access to different, to some of MeaningCloud's API as RapidMiner's operators. We'll see that in a minute. But basically, these operators are topic extraction for the topic extraction API, text classification for the same API, sentiment analysis for polarity analysis, and lemmatization that expose part of the functionality of the part-of-speech tagging API. And most importantly, you can also access your personal resources, your dictionaries, your classification models within RapidMiner, which gives you, as we'll see later, text analytics of the highest quality. So let me show you a little bit about how it works, and for that we'll begin to present our practical case today, in which we are going to analyze a few comments from Amazon. We have 1,500 food reviews from Amazon that can be downloaded via Kaggle, and this is the look of it. Essentially, it has some structured data like different identifiers, or for example, very important, the score, the number of stars that the user gives to each product. As you see, it's a numeric value from 1 to 5, in fact. You have this helpfulness numerator and denominator that has that contains information that Amazon provides to the reader of a specific product in terms of do users of this review consider it helpful. And also we have unstructured text in the form of a summary that it's created by the user as a kind of a title of the comment, and also the full-length comment, which is in this field called text that contains all the comment about the product. So let's go again to RapidMiner and see how we can use this MeaningCloud extension. So let me delete this for a moment. I'm going to create a very simple workflow that performs the topic extraction and sentiment analysis of our data. So our data are here, food reviews. I just drag and drop it. And also I need to do the same for topic extraction API. You see it's within extension, which basically are the plugins created by third-party companies. And MeaningCloud, topics extraction, I'll drag and drop it, and also sentiment analysis. Again, to connect my data to both APIs, I need to use a specific operator, which is called multiply, which essentially allows me to connect my data to both of these APIs. Okay. What I need to do next is to configure my operators. To do so, I need to go again to my MeaningCloud account and go and fetch my license key, you see here. Back to RapidMiner. I click on my operator and I configure it using my key. Very important, I need to define the attribute on which the topic extraction function operates, and this is, if you remember, the text attribute. Text language will be English and output language will be English too. And the same for sentiment analysis, my key. Again, we will be analyzing the text attribute, English language again. And what I'm going to do now is to connect the output of the operators to the output of the workflow, okay, so that we can visualize the results. And only because the data set is very long, and if we would like to analyze that now, it will take several minutes. I'm going to just to use a subset of the data set. I'm going to use this operator called filter. Okay, I'm going just to select a few of the records, like 5, for example. And then I just go and click on this arrow. And you see it's running the sentiment analysis. And after that, he will be running the topics extraction. And now it had presented both results on my screen. You see here the result essentially is my original data set with my identifiers, helpfulness, score, etc. And it has included several additional attributes. Most important is polarity, which identifies the sentiment of the document. Some of them are neutral, some positive, negative. We also have positive plus polarity and negative plus, but none of them seem to be in this category. We also have a measure of confidence in the sentiment extraction, a measure of agreement, meaning in a certain comment you can have different opinions with different polarities. So disagreement means the system has found polarities of different signs. Agreement that all the polarities have the same sign. Also a measure of the writer is using a subjective or objective language, meaning it is expressing basically a fact or an opinion, and also a measure of the irony of the language. And that's for the sentiment analysis. As regard the topics extraction, it's a similar result. We again have my original data with my numeric attributes and my original summary text, etc. And the system has added some additional attributes that have to do with the concept or the entities that it has found on the text. For example, con-noodle mean it has found the concept noodle only in text number 1. You see this 1 means one appearance of the concept in the text, but no appearances in the other text. You see one of these columns for each of the concept that the system has found on the collection. Okay. So essentially, this is the result of this trivial text analytics analysis using RapidMiner. You see how easy and how powerful is the possibility to combine these text analytics operators using drag and drop in your analytics workflow. Our next step is trying to do some more interesting analysis and trying to solve some to answer some questions that have to do with the numeric attributes and the unstructured attributes of our data sets. For example, first one will be from a combination of text and data perspective. One of the first questions I can ask is there any relationship between some of the structured attributes and the unstructured attributes? For example, is there any relationship between the score of the comment and the sentiment that I have found on the comment, which in statistical terms take us to the calculation of a correlation between both attributes. So what I'm going to do in RapidMiner is to use the numeric score that goes from 1 to 5, okay, on one side. And on the other side, I'm going to use the polarity that, if you remember, have 5 values from N plus to P plus. I'm going to convert that into numeric values from 1 to 5. and then I'll be able to calculate a correlation between both two attributes using RapidMiner. So let's do it in the system. I'm going to, again, clean my canvas. And I have prepared the workflow, which is this one. Okay, hopefully you can see it well. Essentially, what this workflow does. Okay, first we retrieve our data. In this case, we are going to use the whole collection. I'm going to select some of the attributes that I'm going to use in my analysis. In this case, I'm going to use a score, summary, and text. I'm going to use my sentiment analysis. Again, I'm analyzing the text attribute that contains the full comment. I'm going to reject some examples, basically the ones in which the system has not found a polarity. If polarity is known, I'm going to filter out those results. And then I'm going to turn the textual labels, P, neutral, N, etc., into numeric values. So first I need to map these to some numeric strings from P plus to 5, from P to 4, etc. And then to turn these numeric strings into numeric values. Okay, I need to parse the numbers in these strings. And I now have all my data ready for calculate the correlation. And the way to do is using this operator in RapidMiner that in fact calculate the correlation among all the attributes in the example set. Okay, so instead of running the calculation that will take some minutes, I'm going to present you with the results. First of all, the resulting example set. If you remember, we selected some specific attributes, and then we have added the polarity-related attributes. In this case, you see the polarity instead of the P, N, etc. These labels have been replaced by these numbers. Okay. We also have the additional polarity-related attributes. And if I go and calculate the sentiment, the correlation matrix, this is the result. Okay, let me show you on the PowerPoint. So you see all the attributes in the example set, in this row and this column, and in each intersection we have the correlation between those attributes. The one I'm interested in is the correlation between score and polarity, which is obviously the main and the same as the correlation between polarity and score. Okay, we found it to be near 0.5 correlation coefficient, which is not very low. We also find here different correlation between all the other attributes that are less interesting for us at this time. Anyway, what I wanted to illustrate with this example was not the value of the final correlation, but the possibility to combine these numeric attributes and the text-based attributes and find answers to interesting questions in a very agile and a very easy way using RapidMiner. Let's go for another question. For example, imagine I am interested in discovering if certain attributes appearing in the comment have a certain impact on the sentiment. For example, the sentiment tends to be negative if the usefulness of the commentary is low, or if the commentary talks about a specific category of products, for example. And the way to answer this question is building a prediction model for the sentiment. And to do so using RapidMiner, what I'm going to do is use some training set that includes my attributes like the concepts, the usefulness, etc., and the sentiment. I'm going to run RapidMiner algorithms that infers a rule-based model, a model that will enable me to predict the sentiment based on the other attributes, okay? And then once I have my model, I'm going to validate it. And I'm doing so by using a different set, a test set with different comments, okay, with their attributes and their sentiment. And I'm going to pass the set through my model to see what's the result in terms of the predicted sentiment. So this step will add another attribute that will be the predicted sentiment that will be the same as the true sentiment or different. In this case, the model will have failed in the prediction, and I'm going to evaluate the quality of this model. So very quickly to do this into RapidMiner, let me delete that. Going again to my design and open this other model. I'm going to show you it very quickly. What it does, essentially, we're doing sentiment analysis to add a sentiment attribute that we will call the true sentiment. We're selecting some attributes, then I'm going to do the topic extraction to add attributes related to the concepts and entities within the comment. I'm going to filter some examples as before and rejecting all the data where no polarity has been found. And then for simplicity purposes, I'm going to aggregate the 5 sentiment categories into 3, okay, to make the model easier. I'm going to call P and P plus positive and N plus negative, okay. I'm going to define polarity as my target variable, my dependent variable, the one I'm going to predict. And I'm going to create my training set and my test set. I'm going that with this specific operator in which I use 70% of my data for training the system and 30% of my data for testing the system. Then I'm going to use this particular RapidMiner operator that inducts a rule-based model for predicting the sentiment. The result of this will be a model. And then I'm going to use the model for validation. First, I'm going to take the remaining 30% data to apply the model on it, okay? And the results of the prediction, I'm going to run it through this performance operator that makes a calculation and an analysis of the quality of the results. Just to give you a flavor of the results of it, this is the rule-based model that RapidMiner inducts from my dataset, just to give you a clearer view. We have essentially all the rules follow a similar pattern in which if certain attributes appear, okay, the prediction of sentiment is positive, negative. For example, in this particular case, if the concept snack appears in my comment, because it's greater than 0.5, then the predicted sentiment is positive. Why? Because in all 3 cases in my training set where the concept snack appear, all the 3 were positive. Or for example, in this other case, if the concept money does not appear and the helpfulness numerator is 1 or bigger, and the concept mistake does not appear, the predictive sentiment is positive, because among all those comments that fulfill this condition into my training set, the huge majority, 340 of them, have a true positive sentiment. So this is the model. We apply that to my test set, and the results of this quality analysis, if you want, is this one. Okay, I'm going to show you on the slides. The system gives me aggregate accuracy measure, which is not bad, 78%, and also it gives me a quality measure disaggregated by the different sentiment classes. How can we read this, for example? And this column. So in all the cases that have a real positive polarity, the model assigned a positive polarity only in 346 cases, which mean the recall of this class is very high, is 97%. And in a similar way, this row, it's about precision. In all the cases where we predicted a positive polarity, only in 346 cases the polarity was really positive. So the precision of the predictive of the positive clause is 80%. So again, the model is not bad. It has relatively good predictive capabilities, but the important thing is not the numeric results of the exercise, but to show you how easy it is to use the unstructured content in your data to really answer interesting questions. So finally, what this is good for? We have many different applications in which we can apply this kind of combination. In general, we have my structured data, for example, in this case, customer data related to contractual or demographic customer data, or the consumption or the product use that he's making. But we can complement that with unstructured sources like, for example, conversation and interaction through the contact center or social comments, for example. And really we can enrich my predictive models so that first they have a increased predictive capability, okay, and also they can produce insights which are more actionable. Okay, for example, using this enrich model, I can detect that a certain user is criticizing me on social media, okay, for example, so I really can take some corrective action related to this situation. The areas in which I can apply this philosophy are very different. For example, we can use that for root cause analysis. In this case, for example, imagine a customer survey with structured questions or an NPS analysis, and you also use open-ended question to try to identify the why behind these particular scores, for example, or for example for fraud or churn prevention. You can augment the typical database fraud analysis models with information from, for example, from social media or your contact center to detect some suspicious behaviors or things that make you predict that the customer is about to leave or similar. Or for example, for segmentation, targeting and scoring purposes, you can complement your data with additional demographic or psychographic information that you found from different unstructured sources, so that you can enrich your model with additional attributes like lifestyles, brand affinities, etc., that really can enrich your models. Or for example, lately in the areas of people analytics, that is related to, for example, the voice of the employee analysis, where you can complement your climate surveys with information from exit interviews, resumes, etc., as a way to detect which are the behaviors or the skills of your top performing people, or detect a situation in which a value employee is about to leave or similar. Finally, a final mention of one of the differentiating attributes of our tools is the one that enables you to get a very high quality text analytics. Obviously, text analytics is not perfect. It's based on statistics and artificial intelligence attribute, and everybody's worried about the quality and the precision of text analytics. We've found that this quality heavily depends on the level to which you can adapt your text analytics to your domain. For example, imagine you are analyzing opinions from banks' customers. For example, it's interesting to detect, unambiguously detect mentions of your organization, your competitors, your brands, etc. Or for example, to classify text according to useful taxonomies like the product families of the bank, or the communication channels of the bank, or for example to adapt the subtleties of the language in these specific industries as relates to the sentiment. For example, if a customer says this is the highest interest rate in the industry, it may be positive if he's talking about his deposit, but it may be negative if he's talking about his mortgage. So it is very important to be able to adapt your text analytics engine to your specific application and domain, and this is one of the strong points of MeaningCloud. We have different graphical tools that enable to extend your ontology, to create your classification model, and to create your sentiment models without coding, without being an expert in linguistics or similar. We don't have time to cover that in depth today, but I encourage you to visit our blog and see some of the webinars that we presented about the issue. And finally, some of the things that will come in the next months. The product is evolving. We have just launched the extension, but in the coming months we plan to improve the usability, to enable some features that are already present in our APIs, for example, language identification, or the ability to perform aspect-based sentiment analysis, or part of speech tagging or text clustering, that are already available for the within the APIs. Expose them also as RapidMiner operators, and also totally new features of the product, like vertical packs that enable you to do a very high quality text analytics for specific industries, or APIs for emotion detection or intent detection that will also be available for you to use as part of the RapidMiner extension. And finally, as conclusion, you now have the ability to very seamlessly integrate MeaningCloud within RapidMiner. If you are a MeaningCloud user, this means you can really extend your text analytics with the ability to create very complex predictive analytics workflows. And if you're a RapidMiner user, you can not only do database analytics, but can really embed text analytics within your text analytics workflows. At the end, all users have the possibility to multiply the value of their models by combining your traditional structured data with this new world of text analytics. And that's it from my part. I don't know if you have any questions. If you want to ask anything. Yeah, we had some question, some repeated question about language availability. In general, yes, we presently cover different languages in MeaningCloud, English, Spanish, French, Italian, Portuguese, and Catalan. And because some customer engagement, we should be launching Russian, Mandarin Chinese, and Arabic. And also we have questions about the ability to perform sentiment analysis in non-English languages by customizing the dictionary. Well, in general, as I mentioned, we have many other languages apart from English, and obviously customizing the sentiment analysis can enable you to increase the quality and the precision of your sentiment analysis in those all languages. Okay, so I think that's it. If there are no other questions, just wanted to remind you that we will be publishing everything, the recording of the webinar and all the contents, all the models, the data sets, the RapidMiner processes as tutorials in our blog. And that's all. Thank you very much for attending this MeaningCloud webinar, and we hope to see you again soon here. Take care and goodbye.